Alright, so we've talked about a lot of different things, the factor theorem, possible rational roots, and so we're going to start putting all of that together to actually find all of the zeros of this polynomial, 4x cubed plus 12x squared minus x minus 3. I didn't write it down, but we are given that this function has at least one rational root. That should tell us that we can go ahead and go the rational roots theorem route. So I'm going to start by listing all of the possible rational roots for this. Remember, that is the factors of the constant divided by the factors of the coefficient, the leading coefficient. So the factors of 3 are 1 and 3. The factors of the leading coefficient are 1, 2, and 4. So I'm going to have 1 over 1, 2, and 4, and 3 over 1, 2, and 4, all of them positive or negative. So I'll have plus or minus 1 over 1 is 1, plus or minus 1 over 2 is a half, plus or minus 1 over 4 is a fourth, plus or minus 3 over 1 is 3, plus or minus 3 over 2, and plus or minus 3 over 4. So these are all my possible rational roots. Since I know that this polynomial has at least one, I know that one of these has to be it. So there's only one sign change here, right? I go positive to positive, nothing, positive to negative, there's one, and negative to negative, nothing. So I know there's one positive real solution. So I'm going to start with the positive. And we're just going to test to see, so these are roots or zeros, and we looked at the factor theorem. That tells me if I plug one of these numbers in to the original function and I get 0, then I know that's the 0, or that's the root that I'm looking for, right? So I'm going to start with just positive 1. I'm going to plug it in, h of 1. So I get 4 times 1 cubed plus 12 times 1 squared minus 1 minus 3. So this is 4 plus 12 minus 1 minus 3. You can already see this is not going to equal to 0. I think this actually equals to 12. So it's not 0. Well, this does equal 12, but it's not equal to 0. So I know positive 1 is not a 0 or a root of this function. So I'm going to go on. Let's do negative 1. So if I plug in negative 1, and of course you could use a basic calculator for this. So I'm going to get negative 4 plus 12 plus 1 minus 3. Again, this is not going to give me 0. I think it actually gives me positive 6, which is not 0. Alright, so let's keep rolling. I'm going to skip over all my fractions. If I don't have to work with them, I don't want to, right? So I'm just going to go to positive 3. Let's see what 3 gives me. So I'm going to test out h of 3. So I get 4 times 3 cubed plus 12 times 3 squared minus 3 minus 3. 3 cubed is 27, and I am actually going to break out my calculator. So I get 108 plus 108. I could actually probably stop right there. I know 108 plus 108 minus 6 is not equal to 0. Come on, I want a whole number. So I get 4 times negative 3 cubed plus 12 times negative 3 squared minus negative 3 minus 3. So I get negative 108 plus 108. Plus 3 minus 3, and look at there. Negative 108 plus 108 is 0, and 3 minus 3 is 0, and 0 plus 0 definitely is 0. So ding, 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 ding. Negative 3 is my 0, my rational 0. I may have more than that. Come back up here real quick. This is a third degree polynomial, so I know I'm going to have 3 total solutions, and I found one of them. It's negative 3. So we're going to break down this cubic using the fact that negative 3 is a 0. We'll be able to break it down into a quadratic by using division. So we can either use synthetic division or we can use long division. If I use long division, I need to take my 0 and turn it back into a factor. So instead of -3, I would have x plus 3, and then you can do the long division. I'm all about synthetic division if I can use it. We are dealing with linear factors, so since I'm dividing by something linear, I can go ahead and use synthetic division. So we're going to use synthetic division to divide out this 0 and see what I have left. So I'm going to use my 0, -3, and all of the coefficients from my original problem. So I have 4, 12, -1, and -3. Bring down my 4, multiply, add, multiply, add, multiply, and add. So I end up with 4, 0, -1. What does that tell me? Long story, that tells me that 4x cubed plus 12x squared minus x minus 3 can be rewritten as x minus x plus 3 is a factor. And since this was a cubic, I divided by linear and knocks it down by 1 degree or 1 power, so that cubic turned into 4x squared plus 0x minus 1, or just 4x squared minus 1. And so now again, you can't see that, we are on our way to writing this in factored form, or at least knowing what all the factors and zeros are. We want them to be able to write this, to find all the zeros. I need all of my factors to be linear. I have linear here, but this is a quadratic. What's nice now, though, I have lots of different ways to solve a quadratic. I could use quadratic formula, I could try and complete the square, I could try and factor it. This one, notice, is missing the b term, so I can just set it equal to 0, get x squared all by itself, and take the square root. So I'm going to go ahead and do that. I'm going to solve 4x squared minus 1 equals 0, add 1, divide by 4, and now I can take the square root. Remember our properties of roots or radicals, we can separate. If I have division, I can separate the two radicals and take the square root separately. So square root of both sides is going to give me plus or minus the square root of 1/4. The square root of 1 is 1, and the square root of 4 is 2. So this actually simplifies to plus or minus 1/2. And so positive 1/2, negative 1/2, and -3 is 3 total solutions. This was a cubic, so I did find all of my zeros. So I have x equals -3, -1/2, and positive 1/2. Those are all the zeros of this function, or this polynomial. So backtrack real quick, what did we do? I had a cubic. I used possible rational roots to find a 0. Once I found the 0, I used it with synthetic division to break down the cubic into a linear and a quadratic factor. The point of doing that, I have all different tools to solve a quadratic. Again, we used what we call the square root method to solve this one, but we have quadratic formula, completing the square, factoring. So if we can break the polynomial down into quadratics or linear, then we can solve it. So this one was a cubic. I only needed to find 1 0 to break it down into a quadratic. If I had quartic, something to the 4th power, I would really need to find 2 zeros to break it down. So I would do synthetic division. I would have a cubic, and then I would need to find 1 more 0. Do synthetic division again, and then I would have a quadratic that I could solve and break down. I'm going to show y'all something real quick. Some of you may have caught it, some of you may have not. This won't always work, but if you are on the up and up of your factoring techniques, if you look at this polynomial, there are 4 terms, which automatically tells me this is a good candidate for grouping. I can take the last two, -3 and -1. -3 divided by -1 is +3, and 12 divided by 4 is also +3. So this tells me that most likely grouping is going to work. So I'm going to try and solve this by grouping. The first 2 terms, a 4x squared, can be pulled out, leaving me with x plus 3. If I factor out a -1, I get x plus 3. And again, by using grouping, I pull out their common term, which is x plus 3, and I'm left with 4x squared minus 1, which is where we arrived by doing all of the rational roots and synthetic division and all of that. Is this a correct way? Absolutely. But if you are, again, like I said, on the up and up of your factoring and you catch little things like this, it can absolutely save you time.